Welcome back. This is an Aleks training video on solving for a gaseous reactant. What you're doing here is stoichiometry, but you're doing it embedded in the gas laws. And if you remember, the ideal gas equation is PV equals nRT, and so you're going to need PV equals nRT for this. So the first question, it's talking about sodium azide, which is it's a powder that burns very quickly in a flash and inside your steering wheel, and it inflates your airbags with nitrogen in just a split second, in a part of a second. So the first thing they're asking is to give you the chemical equation and balance it for sodium azide decomposing into nitrogen. So you're going to need that first. You'll need some sodium left over too, of course, because you have sodium here. But if you have sodium, azide is the triple nitrogen, and you're decomposing that into nitrogen gas and sodium. Okay. They also ask for the physical state symbols. Okay, so that's solid sodium azide. You'll end up with solid sodium and then gaseous nitrogen. Okay, remember it's N2 because it's nitrogen's a diatomic. And they went ahead and gave it to you too. Dinitrogen just means that it's N2. All right, so let's balance this. Sodium and sodium is fine. 3 and 2. So I need to make them both even. So I'm going to make this one 2. So that's now 2 times 3 is 6. And that'll make this 3 times 2 is 6. All right, and then 2 NAs makes this 2 NAs. So it's 2 NaN3S yields 2 Na solid plus 3 N2 gas. All right, so that's the answer for the first one, so I guess that's A. And then you'll use it in a minute. Suppose that 54 liters of dinitrogen gas are produced in this reaction at a temperature of 20 Celsius, exactly 1 atmosphere. So if I were to look at the balanced equation like we normally did for stoichiometry, I don't know where to put the temperature and the pressure and all that. So what you're going to do is you're going to put it in the PV equals nRT formula. I'll show you in a second. Calculate the mass of the sodium azide that must have reacted. Well, if I have PV equals nRT, I'm not going to have mass. N is number of moles. So all I can do is number of moles, then go through the periodic table to find out mass. We can do that through the molar mass in a second. All right, so fill in what we know. We know that the volume is 54 liters. The pressure is 1 atmosphere. Number of gas is what we're trying to find. R has to do with whether it's atmospheres. The R that you choose, there's 2 different R's. The R that you choose if you have atmospheres, you'll look it up in a table. It's 0.0820574. Okay, liter atmospheres over Kelvin moles. I guess I should write my units. I never do. I'm lazy. Temperature has to be in Kelvin. It doesn't work in Celsius because R is in Kelvin, and so if you put it in Celsius, your math would all go crazy. So I need to add 273 to the 20. It says that I have 20 Celsius, so 293.15 Kelvin. All right. So get N by itself. I'm going to have N equals 54. 1 times 54 is 54 over R. And over Kelvin. Okay. That means that N equals 2.2448 moles. This is nitrogen. All right, so now I can go back into the balanced equation where we've got nitrogen and we want to know the sodium azide. So I'm going to do a ratio. Looking at the 3 and the 2, I say that 3 moles of N2 is to 2 moles of NaN3 as, now I've got what we just found, 2.2448 moles of N2 is to X. Okay, so when I do that, I'm going to get X equals, I'll put a few digits here. I'm going to round right at the very end. I don't like to round in the middle. 496, at least 5. Okay, so this is moles of NaN3. When I look up sodium and nitrogen, I've got 23 and 14, 14, and 14. Okay, when I add this all the way up, I'm going to get 65.0099 grams per mole. So I'm going to have to multiply that by the 1.4. So I'm going to say 1.4965 moles of NaN3, and there in 1 mole of NaN3 there are 65.0099 grams of NaN3. Okay, that will give me, what is it, 97.3 grams NaN3. Let's check quickly to see how many significant digits I have. 3 is always a good number. I like 3 because it's lots of times it's 3. 54.0 is 3, 20.0 is 3. Okay, there you go. So it's going to be 3 significant figures, and so your answer is going to be 97.3 grams. And then just to copy this one again, it's 2 NaN3 solid yields 2 Na solid plus 3 N2 gas. Okay, love it.